Hey guys, today we are going to be solving for units of K. This is part of AP Chemistry's rate laws chapter. This is chapter 12. I'm not sure what unit it is, but let's just get straight into it. So the first is A, the rate of a chemical reaction. And in order to solve for the rate of chemical reaction, the units for rate are always moles per liter times second. This is the same as molarity over second as molarity as moles per liter. I'm not going to erase this, but I'll just keep it right here. Okay. B, rate for a constant zero order rate law. Now, when they're saying a constant zero order, you have to consider that a constant zero order, when you write the rate, your rate law is just equal to K. That's the only thing you have in a constant zero order, which means that your unit must equal A, right? Because they're moles per liter per second. So it's going to be moles per liter times second. Once again, like this one. These are sort of the silly ones. Okay. Next we have our first order rate law. Okay, so there is a little trick for solving for units of K, and that is that K is equal to 1 over molarity, and then the order minus 1 times your seconds. Okay, so rate for a first order law. Well, when we think of first order, we know that our rate is equal to K times the concentration of a reagent. That's it. So there are two ways you can sort of approach this problem. The first way is like the algebraic way without this formula, let's say. So we know that our rate, like we just said, is always equal to moles over liters times second, molarity over liters, whatever. And then that is going to be equal to K of, then our concentration right here is, again, moles over liters, which means that that is equal to K of moles over liters. In order to isolate and solve for K, we will find out that once you multiply this liters and then you divide and then you also factor and consider this moles and get rid of it and you isolate K, your units for K will be S to the negative 1. But another way to solve is using this little shortcut equation. And in order to use this is what you do. So we have that this is a first order rate law. First order means that it's first order. So we look at K, we're plugging it into this equation, 1 over the molarity to the order, which is first, minus 1 times our second. Now, that gives us 1 over molarity to the power of 0 times second. And we all know that anything to the power of 0 is 1. So 1 over 1 times our seconds, which is equal to S to the negative 1. So our units for K for first order are going to be S raised to the negative 1, or you can write it like 1 over seconds, whatever you prefer. I'm just going to keep the units here in case anybody wants them for reference. Okay, now we are going to move to part D. Part D says the rate constant for a second order rate law. Now, once again, you can do the algebraic way, you can do however you want, whatever makes you comfortable. So a second order rate law is that the rate is equal to K of A to the second, right? So the algebraic way would be moles over liter times second equals K mole over liter squared. And now, again, it's not hard to do the algebra here. You distribute, cross out, whatever, but it's just more efficient to use this formula, and this formula is not hard to memorize. So let's use it. K equals 1 over our molarity to the order minus 1 times second. And we said that it's a second order, so 2 minus 1 times second. So that means that K is equal to 1 over molarity to the power of 1 times second, right? Or just molarity. You do not need to put, obviously, to the power of 1. So, now, molarity to the power of 1 on the bottom is the same as m to the negative 1, s to the negative 1, right? We all know this, right? But molarity regularly is written as moles over liters. So because it's to the power of 1, because it's flipped down, I think of it like this. I think of it as, instead of being moles over liters, it's going to flip, and it's going to become liters over moles times second, because this is our normal. This is our not normal molarity. This is our normal molarity, where moles are on the top. So the inverse would be the inverse. Okay. Now, part E is the third order. A lot of people think this one's scary because the units are larger, but it's really not with this formula we have here. E says rate constant for a third order rate law. Third order. Now, again, you can solve this algebraically, but I'm not going to. I'm just going to plug in my formula. We're going to say that K is equal to 1 over our M, molarity of the order minus 1 times second, and we're in third order, 3 minus 1, which means that this is equivalent to K equals 1 over molarity squared times second, which is once again equal to -2 times second to the negative 1. Once again, we established that it would be inverse because it's on the bottom. That's how I like to sort of interpret it in my mind. So instead of it being just liters, it would be liters squared. So our K units would be equal to liters squared over the moles squared, once again, times by second. This would be your unit for K, and these are your units for K for a regular 0 order, first, second, and third, if you want a screenshot or whatever you want to do.